There's ample evidence to suggest that heat waves are becoming more frequent and intense in many regions of the world. This trend is driven by a combination of natural factors, such as changes in atmospheric circulation patterns, as well as human-caused climate change. The growth of urban environments coupled with these climatic changes has resulted in growing concerns regarding temperature mitigation strategies amongst urban planners and policymakers. Rising global temperatures can increase the likelihood of extreme heat events and also make them more severe when they occur. Heat islands refer to urban areas that experience higher temperatures than surrounding rural areas due to human activities such as building materials, transportation, and energy consumption. These urban areas typically have a higher concentration of buildings, roads, and other infrastructure that absorb and trap heat, leading to increased temperatures. Heat waves can have serious impacts on human health, particularly among vulnerable populations such as the elderly and individuals with pre-existing medical conditions. They can also lead to reduced crop yields, increased energy demand, putting more strain on an already fragile grid, and exacerbate pre-existing socioeconomic issues. Our design focuses on roads, which occupy on average 30 to 35% of urban spaces. The technology provides an innovative, cutting-edge, and scalable solution to adverse heat effects within built environments. The goal of our design was to capitalize on heat differentials to generate small amounts of electricity to make the temperature of the local environment more temperate. We conceptualized this roadway design embedded with a thermoelectric material used to capture heat and convert it into electricity via a device called a thermoelectric generator. Our design began with schematic diagrams outlining the invention, documenting the heat source, and the thermoelectric generator series that produced electricity. Our prototype is pictured here and was deemed successfully engineered, yielding a positive net generated charge. By equipping roadways with a series of thermoelectric generators, we can ideally capture enormous amounts of heat. Further testing of the asphalt in which this technology will be embedded will allow for a better picture of the effectiveness of the thermoelectric generators and enlighten us as to how best to optimize thermal capture. Our solution explicitly accomplishes the following 4 sustainable development goals: industry, innovation, and infrastructure, reduced inequality, sustainable cities and communities, and climate action. But this can also be indirectly tied to improving other goals as well. Heat islands disproportionately affect marginalized populations by exacerbating pre-existing issues. Lower income communities often reside in heat islands, and this is problematic because they can't pay higher electricity prices, which can leave them no choice but to suffer from adverse health effects. Future trends project that demands will be high for this technology as environmental conditions will worsen and necessitate technological approaches. With this technology, we can capture heat in a scalable way. There is currently no technology on the market today attempting to accomplish what we are doing here. On a macro scale, this adaptable technology could mitigate enormous amounts of heat. The appeal to stakeholders are 1, social equity improvements, 2, safety improvements, and 3, long-term economic benefits. The potential electrical capabilities of this technology could power urban lighting, which has been proven to reduce crime and make cities safer, especially for female populations. It can also power traffic lights or pedestrian buttons, and if applied, they can make urban/traffic and electrical systems more resilient because they are decentralized and independent from a central grid. There is no market for this as of right now, and this presents an attractive opportunity. Thank you.